check. Teacher William, can you just test your microphone?
Mic check 1, 2. Hello, can you all hear me well?
Yes, you are clear. Okay. Can we request a volunteer from one of the schools to lead us in a word of prayer? Can we just choose Mary Assumpta? Mary Assumpta, get for us a volunteer to lead us in a word of prayer. Mary Assumpta, unmute. Mary Assumpta. Okay. Yes, Mary Assumpta, we can start. Mary Assumpta. Oh, sorry. Mary Assumpta, you can start. Okay. I'm failing to get from Mary Assumpta. Teacher Robert Alice, can we get from you? Okay, Mary Assumpta, we can start.
Let us pray in the name of the Father and the Son and the Holy Spirit. Heavenly Father, we thank you for the gift. We thank you for your protection throughout our lives. We thank you for bringing us together at this hour of the day. Oh Lord, Father, we pray to you to start these lessons. Father, shower us with your precious blood. Send forth your Holy Spirit to be with us, to guide and protect us, to open our minds as the students, to make us understand all that is going to be taught for us. So send forth your Holy Spirit upon the teacher who is going to teach us, to give us the true knowledge that he had and everything that we need from him. May you also guide and protect us throughout this time. We ask this in Jesus' name. Amen. In the name of the Father, and the Son, and the Holy Spirit. Amen.
Thank you so much, St. Mary's Assumpta, for the wonderful prayer. I want to welcome you once again for this session. Thank you so much for coming. Today we are going to deal with practical paper 3 and 4. And we want to welcome everyone that has joined in this call. We want to thank you so much for your consistency, and also we want to thank you for your time and also for sparing your data to join this noble cause. Allow me now to welcome Teacher William to take us through his presentation. We shall share again in the chat the questions as such that you can be following. Teacher William, you are most welcome.
Okay, thank you so much, Mr. Kaziva. Let me still hope I'm still loud and clear.
Yes, you can.
Okay, I want to maybe first of all put a disclaimer. As you know, when we're in the villages, sometimes the networks may be on and off. Just in case I go off, I'm ready, I'm prepared. I'll be switching networks in case one goes off. I'll be switching template. So meaning, in case I have a hiccup, you be patient for just a few seconds, I'll be back on. I want to welcome everyone who has tuned in today. And I want to share my screen so that I can be moving together. I don't know if my screen is clear to all of us. Mr. Kaziva, can everyone get my screen?
Yes, your screen is there, very clear.
Okay, so like already introduced, we are going to be looking at the introduction to UCE physics, practicals, that is paper 3 and paper 4. I see a macro Robert raised the hand. I don't know what is the concern. A macro Robert.
Yes.
Robert, unmute.
Are you getting me?
Yes, we can hear you.
No. Now I wanted to confirm that my screen is okay. I can see what's appearing here.
Okay, okay. All right, thank you so much, Mr. Robert. So like we said, we shall be looking at we shall be trying to be quick to go through some of the few tips and practicals, paper 3 and paper 4, UCE. My name is Ahewa William, and I teach in Chigarama Secondary School. It is found in Mitoma District, Western Uganda. So before we dive into other details, I'd like to share some quick tips. One is we already know that paper 3 and paper 4 is comprised of 3 questions. Maybe some people sometimes think paper 4 is so much different from paper 3, but the reason for having paper 4 was put there specifically to accommodate learners. As you know, our schools, sometimes they don't have enough resources and therefore they don't have enough apparatus. That's why they decided, they realized that it may not be possible to have all learners doing one practical in one day. And they decided to create that paper 4. So it is not so much different. It's actually what we do in paper 3 is what is done in paper 4, only that we need to create another room for another group of people. So both papers, that practical paper comprises of 3 questions, whereby the first question is compulsory, and we always choose between between question 2 and question 3, whereby question 2 comes from the topic of optics or light, and the question 3 comes from the part of electricity. Question 1 is always compulsory, which is for mechanics. This paper takes 2 hours and 15 minutes. So if you look at that, it basically means that each number is supposed to cost you 1 hour. You're supposed to spend 1 hour doing one number and then another hour doing the other number. The 15 minutes to help you prepare yourself. And that is why we advise candidates, please always use these 15 minutes to read through all the questions, all the 3 questions. Question 1, we know it is compulsory. It will help you to be planning, to have a picture of how will the table of results look like. Probably you start planning, how am I going to be handling these apparatus? You even get a chance to look at, am I having all the apparatus with me? And you also use those 15 minutes to read through question 2 and read through question 3, probably so that you can make an informed choice. Because remember, question 2 and question 3, you're supposed to choose one. Now, some people or some schools, you find that the learners are very okay to do all the 3 numbers. And now that in itself can tend to cause panic amongst candidates, whereby one may even fail to choose because he or she sees that everything is doable, and as a result, the person ends up failing to choose. So use these 15 minutes to first read through all the questions, especially the question 2 and question 3, so that you're able to choose, to choose in advance before even you start doing the practical. You know, I will either be able to do question 2 or I will be able to do question 3. Sometimes we can even choose a question, you do it, along the way, it doesn't come out the way you expected it, or you don't get the results you desire. So you may find you get forced now to shift and you do the other question because all the 2 sets of apparatuses will be at your disposal. So reusing the first 15 minutes, you have already had the picture of how question 2 is going to look like and how question 3 is going to look like. As a result, you'll be able to, if you choose to easily switch from one to the other, you already know where to start from. So that's why we advise you to do that. And after that, you're supposed to read procedures carefully. And I mean it, that's why I've written it in capital letters. Read procedures carefully. That's why when we are teaching you, we tell you candidates that a learner, someone who doesn't know physics, can end up passing a practical if that person follows procedures. Because those procedures are there, they are guiding you. They are telling you, do this, do this. Now, the problem we always have with candidates is they tend to, someone wants to jump procedure 1 and procedure 2, and they want to look at 5. They want to do what procedure 5 is saying before doing or reading what procedure 1 and 2 have said. And as a result, people or students will reach along the way and get stuck. So those are the problems of not reading procedures carefully. So that's why I advise you, please read procedures carefully. Don't use a pencil. I guess this, you've heard it several times. We are not allowed, or we are not supposed to use a pencil in physics practical. So we condemn it with the highest terms possible. Please don't be tempted to use a pencil. All work that you'll do with a pencil may or may not be marked. And the chances are high that it will not be marked, except if maybe you are at the mercy of the examiners, who may say, since the pencil is only in this specific area, let us maybe award. But please don't use the pencil when doing a physics practical. Most marks, I want to give you a quick reminder that most marks are on the table results and the graph. As we know, I could have not reminded you that the physics practical is marked out of 60. So one question takes 30 marks and the other question also takes 30 marks, and the most marks are on the table of results. Some people you find candidates complaining, I don't know how to calculate slope, I don't know this and that. But please take note that the most marks are on the table of results and the graph paper. A table of results will take approximately like 15 marks. The graph will take approximately 10 marks, and then the other calculations you're looking at, like the slope and what, may take approximately 5 marks. Now you here have used the word approximately, meaning they slightly change. So, but that is like the standard. So you realize that most marks are on the table of results and the graph. So if you concentrate on getting your results and doing the 6 things on the graph, you'll find yourself passing the physics practical. These are the common mistakes some students do. Like I started with telling you, where I bolded for you that don't use a pencil. Some students you find they use the pencil, and this is like I told you. That if you use a pencil, so as a result, you find someone has failed the not maybe through the world because they used the pencil. Then poor reading, inability to use the apparatus. I'm going to be sharing some how we can read different apparatuses. This is also another problem. You've been given maybe a meter rule. We all know the meter rule can only record up to, let's say, 100 meters or 1 meter. And you find a student is recording results from a meter rule, and that student is saying that for him or her has gotten a reading like 105 centimeters, which is impossible. Or you find someone is using a meter rule, or let's say protractor, to measure angles, and someone is saying he has gotten an angle of 30.5, which is not true. You cannot get it. So that is also another mistake that affects learners when doing a practical. Wrong accuracies of the apparatus. This I link it up with the what I've just mentioned there. What I've just mentioned up here about the poor reading of the apparatus. You find like I've just given example someone using a protractor and getting an angle of 30.5, of which you cannot measure that angle using a protractor. So meaning you're recording the angles with wrong accuracies. When we talk about accuracies, we are talking about decimal places or significant figures. So if someone records the wrong accuracies of an apparatus, that person will end up getting wrong results, and which will affect their performance in this paper. The other mistake they do is forging results. Students tend to forge results. You find someone has done a practical and they are showing the flow, or maybe they've just memorized it from maybe the practical they've been doing, or they are just thinking, since I'm doing this practical, my interval should be a 1, 1, 1, 1, and if someone starts forging results. So that is also another mistake students or candidates do, which can end up affecting their performance. Improper data manipulation. Here, remember when we are doing a practical, we tend to have in our tables of results either addition or subtraction or division or multiplication. That is what we call manipulating the data, meaning you're doing some algebra. Now, some candidates or a good number of candidates struggle to manipulate data. Like we always even see in the enable reports, when the results are out, it tends to come out as one of the struggles candidates are having, areas where the candidates are struggling, like the inability to manipulate the data. So I will also share slightly how we can manipulate data. And like Mr. Kaziba started by telling us that we had already shared the sample tables of results, which we designed. We shall look at how to deal with some of them. So improper data manipulation is another problem of learners. Poor writing of quantities and their units. For example, look at this. We may be given L out of T, and L was in meters, T is in seconds. And therefore, you end up having a unit of meters per second. Since this is meter up, a second is down. So meter per second. Now, this is the correct way you're supposed to write it. L over T. The meter per second, this unit here is not at any point supposed to be this line of division, because it means now you're trying to give it only T, which will change the whole meaning of that unit. Like you've seen here, I'm showing you this is a wrong way of writing it. You realize this dividing line is capturing this unit under it. If you see this dividing line here, there is L out of T. So the dividing line is capturing this out below it, which makes it now wrong. So that is why we emphasize, if you're writing any quantity that involves a division line, be it a quantity like this, L over T, be it in your calculation, make sure the dividing line is at least relatively horizontal to avoid such a problem. You may find this person here was trying to put the unit just not necessarily putting it below, but due to improper writing of this division line, it has ended up killing the whole meaning. So that is another mistake learners do. On top of that, they tend even change the symbols given to them. That is another issue related to wrong writing of quantities. They change the symbols. You're given small l, someone ends up changing it to capital L. Someone ends up changing it to capital L. Now, when we change it, you have completely changed the meaning, or you've changed the question now. You're setting your own question. So that's why we encourage you candidates, please don't change the symbols given to you. If it is a small letter, use it as a small letter. If it is a capital letter, use it as a capital letter. Use it the way it is given to you. So that is those are some of the mistakes these learners keep doing. Then we have poor time management. Like I told you, you're supposed to use 1 hour on each number. You find someone has finished the number, and maybe you're supposed to switch and start doing the other number, but you continue. Okay. Someone is sharing the screen. I don't know who is that.
Let me disable that thing. Sorry. This is Sengova Muhammad. Sengova, can you stop the sharing? Sorry, Onyango. Okay. Okay, you can share again. Teacher William, can share again.
Are we there?
We are there.
Okay. All right. So I was saying the other mistake is a poor time management, whereby like I was saying we are supposed to spend on each question, like I've said, 1 hour. If any someone has finished question 1, but is continuous, is still attending to it, trying to see that they finish the graph, what, and they, by the time they switch to the other question, poor time then also relying on friends' results. Some people want to wait, someone, or what we call copying. Someone wants to wait, let a friend first finish doing, maybe I'll get the results from this friend. And before you know it, time has gone. And that is how you'll end up failing. Of which, had you started doing your own work, maybe you'd have gotten something. So please, candidates, let us not rely on friends' work. Now, I will quickly share hints on the following. I will share on measuring instruments and their accuracies. I look at data manipulation, addition, subtraction, multiplication, division, like I had told you. I see how we can deal with some tables. I'll combine this with this. I'll combine data manipulation with table of results to be quick because enough time is not our colleague. I'll look at the graph quickly and then maybe slope and intercepts if time allows. Now let's start by looking at the measuring instruments. Some measuring instruments, we measure in physics, we measure physical quantities. And in this practical, we do measure these physical quantities. Now we use different measuring instruments for different physical quantities. You may already be knowing that. Like for example, here length, we have tape measure, meter rule, vernier caliper, micrometer, screw gauge. We realize that each instrument is assigned a specific role. Like for example, if you want to measure the width of a classroom, you cannot use a vernier caliper to measure the width of a classroom. So you'll need an instrument suitable for that, which will end up being a tape measure. You want maybe to measure this the length of a thread. You'll find you need like a meter rule. You want to measure diameter of a big car. You will find yourself in like a caliper to measure diameter of a micrometer screw. So different apparatuses and different roles. We know time. We use a clock or stopwatch. Voltage we use meter. Current we use time. As we use the beam, etc. We have as instruments, we can use in a physics practice depending on what the question is asking for. That's why it's very important sharing with you. When we're measuring instrument, what is very important, and this is the simple formula I will give you. Every measuring instrument has its accuracy. Remember, I told you what accuracy means. The number of decimal places that instrument can measure. That is what we call the accuracy of the instrument. Now, every measuring instrument, if I want to know what is its accuracy, I will need to know the smallest quantity this measuring instrument can measure. The smallest quantity, we mean the division, because that measuring instrument will be having a scale somewhere. It will be having a scale, be it an ammeter, voltmeter, a meter rule, a protractor, a watt. It will be having a scale somewhere. Now, the smallest division it can measure, that is the one that gives us the accuracy of that instrument. Now, how do we get it? I get to look at the interval of this instrument. For example, I may be having an instrument, the numbers are increasing as 1, 2, 3, 4, 5. That is how the numbers are numbered on that scale. So when I look at them, I see that the numbers are increasing in steps of 1, 1, 1. Because from 1 to 2, that is 1. From 2 to 3, that is 1. From 3 to 4, that is 1. So it means it is having an interval of 1, 1. I may be having an instrument, the numbers are numbered or they are written as 10, 20, 30, 40. So it means that instrument is having an interval of 10 because the numbers are increasing in steps of 10, 10. So its interval is 10. Now I will get that interval. I divide it with the number of divisions forming that one interval. Then when I divide them, they will give me what each division is equal to. And the number of DPs of that division, that one division, smallest division, will be the number of DPs of this measuring instrument. Let me quickly take you maybe to a sample. Let's look at a meter rule. Look at this meter rule, for example, here. We see it is starting from 0 to 1, 2, 3, 4, 5, 6, 7. So the steps, the numbers are increasing in steps of 1, 1, 1. So meaning its interval is 1. Now, if I want to know the accuracy of this ruler I'm holding, I want to know when I use this ruler, I'm going to record it, how many DPs. I will come and look for its interval. I know the interval is 1. Now I see between this one interval from this one to this one, there are how many divisions? I see there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 divisions in one interval. So meaning each division, each small division will be equal to this interval, which is a 1 divided by these 10. That's what the formula. That is what I showed you here in this formula here. The interval is 1, the number of divisions are 10. So it means that one small division will be 1 divided by 10, which is a 0.1. Now I have known each division is 1. If I move the next one, 2.1. I got this one, add 1, 2.4, 2.5. Now I have known each one is a 0.1, but also I've seen that this one, which is equal to 0.1, is having one place. 0.1 has a small place, which means that this whole ruler here, everything I'm going to record from this ruler, I should give it a 1 decimal place. Whatever I'm measuring is stopping here at 3. So it means I have to record it as 0 because I need to give it 1 decimal place since I've seen that this ruler has an accuracy 1p. If you look of a vernier caliper, now here you know some candidates may have never maybe tried using the vernier caliper, but we know the vernier caliper, a basic structure looks like this. Now I need also to know this vernier caliper of mine, I'm going to record it how many DPs if I'm going to use it. Maybe before I forget, every measuring instrument will be having unit in which it needs. If you even look at this, unfortunately, is just every measuring bit what they always indicate for you that it is measuring. If it is centimeter, it will be like here. If it is millimeter, it will be indicated. If it is volts, indicated. Take note. Wherever you go and find an equipment that is measuring something, that equipment they will rate there the unit it is using. Now, I see this caliper is measuring in centimeters. I want to know, I should record it how many DPs. We should all remember from I think year 1, when you're looking at the measurements, you looked at these instruments, and you know vernier caliper has 2 scales. It has this one, which we call the main scale, and this small one here called the vernier scale. Now, vernier scale being the smallest thing that I measure, I come and look at and know, or those who didn't know, this vernier scale here, I get each number I get here is divided by 100. So it is centimeters, and I pick the 5 because you can the diagram to be so much clear. But this here is the 0 mark. 1, 2, 3, 5, 6, 7, 8, 9, 10. 10 divisions which make up the vernier scale. Each division divided. If it's the second one, then minus 100. Hello. Hello. Can you hear me, members?
Yes, we can hear you.
Okay, thank you. So I don't know at what point did my network disconnect, but I was talking about a vernier caliper, and I was saying that it has 2 scales, whereby I have the vernier and then the main scale. And for me to know the smallest measurement or the number of DPs I will use, I'll come and look at this vernier. They have the smallest division, I divide it by 100. So for example, if we take a look, this vernier now, what is reading? I'll cut pro, it's a reading me a 2 here. And the first mark of the vernier scale beyond has gone beyond that 0.1 mark. So it implies that the main scale reading is 2.1 centimeters. Now I need to add the vernier scale reading. Look, these other here, which in line with the lines up. Now, if I look and I realize fifth line scale that is in line with the lines up there, then it means that point one add here this 100, which is 0.05. So I'll end up having as 0.2. Now let's note my path. This was how we get this instrument. I realized each one idea from here and they also tend so the 100 give a 0.0. If I 1 divided by 100, 0.01. Now, that 0.1 would be vernier caliper would be the vernier caliper measure in centimeters. If I can, so thing method also has sleeve reading and thimble reading. And if I'm to show you a sample,
Okay, sorry, he's coming back, but before he left, he was talking about the vernier caliper. Robert, you can first make your submission. Robert, unmute.
Okay. I get it.
Yes?
I get it.
Robert, I'm also yeah?
I am saying because of network, we are not getting the host.
Oh, sorry. Sorry. Okay, let's give him some few minutes for him to get. I'm saying sorry about it. Let's give him some few minutes.
Am I back, Mr. Kazuba? Can you hear me?
Yes, now you are very clear. You are clear.
Okay.
Okay.
So I had finished talking about the vernier caliper I'm trying to talk about it briefly so that we can have time to talk about the tables and whatnot. So if we look at the micrometer screw gauge also, it has this is the thimble reading, this is the sleeve reading. It also has two scales like a vernier caliper. Only that a micrometer screw gauge, for it records in millimeters, you record in millimeters, for which you can change that millimeters to centimeters. Now I was showing you an extract. I don't know why this network is now misbehaving. So if we look at this extract from here to here, this is 30, 35. Here it was 25, this is 30, this is 35. This is the smallest reading on the micrometer screw gauge. So it is the one I can consider to get my number of DPs of the micrometer screw gauge. So since I see the interval is 5, 5, 5, I can divide it by the number of divisions, which is 1, 2, 3, 4, 5. 5 divided by 5, it will give me a 1, meaning each one here represents 1. Now, I get every division here I will get, I divide it by 100. So it gives 100 of a millimeter. Now, if I have this reading, for example, I see this is 6.5, 7.5, 8.5, 9.5. This is the reading so far I can see on the sleeve reading, which is 9.5. If I want to get the actual reading of what this micrometer is telling me, is I'll get a 9.5. I have seen, I add there the line here amongst these lines which are here, the one which is in line with this center line here where these numbers are numbered, this center line. Now, when I check, if this is 25 and this is 30, so meaning this is 25, 26, 27, 28, 29, meaning it is the 29th line on the thimble reading that is in line here. Now, it means I'll have a 9.5 plus 29 divided by 100, because I divided this by 100. So it will be 9.5 plus 0.29, which will give me a 9.79 probably. So that will be how I will get the reading of the micrometer screw gauge. But also, you need not forget the main point is I have seen that each line here I divide it by 100, sorry, I divide it by 100. So if this is 25, this is 26, this is 27, 28, 29, 30. If I pick a line, maybe this is a 29th line, I divide it by 100, it gives me a 0.29. That means that the smallest it is recording is in 2 DPs. It means that when I'm recording also my other measurements, I will record them in 2 DPs for the micrometer screw gauge. Not forgetting that the micrometer screw gauge measures in millimeters. We have other apparatuses like other measuring instruments like a stop clock. As you see it here, stop clock, we can have those which have this kind of scale, or the ones that can have this kind of scale. Like I told you, the other method, the other formula I've given you applies to every measuring instrument. If I see this stop clock here, and I want to know how many DPs will I write its recording, I see from here to here, this is 5, because this is a 60, it doubles as a 0 as well. So 0 to here, this is a 5, this is 10, this is 15, 20. So the interval is 5. How many divisions are in one interval? I can count and see. I can check any interval. Let me use this one here. There is 1, 2, 3, 4, 5. 5 divisions in one interval. So 5, the interval 5 divided by the 5 divisions, it gives me a 1. Now, the answer I have gotten, which is 1, does not have any DP, implying when I'm using this stop clock, I'll be recording it to 0 DPs. But if I look at this stop clock here, the interval is still 0, 5, 10, 15, 20, 25. Now the interval is still 5. But if I look at in one interval, how many divisions are there? I see there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I see I have 10 divisions in one interval. So the interval, which is 5, I will divide it by the number of divisions, which is 10, giving me a 0.5, which is having 1 DP. Now it implies when I'm using this stop clock, I'll be recording it to 1 decimal place. Everything I'll be measuring, it will be to 1 decimal place. Even if my pointer comes and stops here, I will not record it as 10 seconds. No, I will record it as 10.0 seconds. We can look now with a stopwatch. A stopwatch is unique, and it measures here. It will be telling you minutes. Here it will be telling you seconds, and here it will be telling you micro or milliseconds. Now, when I take my reading here, a stop clock for it records 2 decimal places, and I mean a stopwatch. Sorry, a stopwatch records 2 decimal places, unlike for a stop clock. A stop clock we've seen for it records to either 1 or 0 DPs, because we've seen the two types sample. But with a stop clock, it will record 2 DPs simply because the number which would be here, you'll divide it by 100, and then you add it to the number which is here on the seconds. Meaning that if here I have 20, 2 and a 0, 20, meaning those is 20 seconds. Now here I have a 1 and a 9. So meaning that is 19 divided by 100, which is 0.19, meaning the actual reading will be 20.19 seconds. So recordings we get with a stopwatch, we take them to 2 decimal places. Here we have sample of ammeters. Still the same rule applies. If you want to know, I'm using this ammeter, and I want to know what will be the recording. You still check the interval. If it is a 0.2, and you see there are 10 divisions, you will get a 0.2 divided by 10 divisions, giving a 0.02, meaning every recording I'll take with this ammeter, it will be 2 decimal places. If I look at this, same thing. If I look at the interval I'm using, 0.2, I divide it by 10, it will be giving me a 0.02. So that is basically how you can know the decimal places of each measuring instrument, be it a voltmeter. The same rule applies. Now let's look at the manipulation of data. Meaning now we want to look at how we can add or divide our data in the table of results. Now that I've talked about the measuring instrument, maybe you have done the practical, you've gotten your measurements using the measuring instrument, and now you want to get to the table of results. Now let me consider table 4. Let me hope members still have it. I hope members have a look at it, but our table 4 looked like this. We had here a U in centimeters and then a V also in centimeters. Now, in that table, maybe we are required to get a U plus V or V minus U. Now, the rule for data manipulation is if I'm going to add anything in the table of results, I will consider the leading row, meaning the row which is at the top. I look at the row at the top. I look at, I'm adding U and V. I'll come and look in the first row. U is here, V is here. I'll be adding these two. Now, what do we do? When we are adding, I look at the number of decimal places of this number and the number of decimal places of the number here. This is a 1 decimal place. This is a 1 decimal place. Meaning when I add them, my answer should also have a 1 decimal place. If I had here 1 decimal place, I'm bringing in another scenario. Suppose I had here 1 decimal place and here it was 2 decimal places. These numbers had 2 decimal places, maybe for example. When I'm adding them, this is having 1 decimal place, this is having 2 decimal places. The answer should take the least number of decimal places. So between the 2 numbers I'm adding, the least number of DP is 1 DP, implying that if I'm adding this 1 DP and a 2 DP, the answer should have a 1 DP. Same rule applies to subtraction. If I'm subtracting this minus this, I will look at the two numbers. Which one is having the fewest number of decimal places? Unfortunately, here all of them are having 1 dp, 1 dp. So my answer will take now the fewest. The fewest we have is 1 dp, because this is having 1 dp, this is also having 1 dp. So my answer should also have 1 dp. But if this had 3 dps and this had 2 dps, then my answer would have taken 2 dps, because 2 dps are the smallest number of dps I'm having. And then after you have added this and this, you have now said I'm adding 1 dp and 1 dp here. The answer is now 1 dp. The rest here below will follow what the boss has said. This now becomes the boss. The one you've done first becomes the boss. What the boss says is what the rest follows. If the boss has said 1 dp, the rest will also do 1 dp. If the boss has said we use 2 dps, the rest will also use 2 dps. But remember, we have seen how you will know the dps of the boss. The dps of the boss, you will determine them depending on what you are adding. If you're adding something having 5 dps, the other one is having 7 dps, then the boss must have 5, because the boss is supposed to take the smallest. Okay. Similar to subtraction, like I've just said, you look at the leading row, you see the dps in one number, the dps in the other number, you take the smallest number of dps. This is 1 dp, 1 dp, the answer will also be written to 1 dp. And once the boss is written to 1 dp, the rest will also be to 1 dp. So that is how we can carry out addition or subtraction in a table of results. The rule remains, it applies even when you're doing your calculations. Like you're doing calculations, you're subtracting numbers. If you're subtracting 2 numbers, you look at the number of dps in one number and the number of dps in the other. You take the smallest. If we look at multiplication and division, let us consider table 3. Table 3, hope you can have a look at it. That table 3 among the samples. Table 3 looked like this. Now, if we look at table 3, before maybe I start talking about table 3, I've put here in brackets reciprocals and normal division. I wanted to remind myself something, because when we are talking about division, there is a division where I may be having a reciprocal, 1 out of something. Then there is a division where I may what I've called normal, like this one here, which is x over y. This is a normal division. Now, the way we handle those two divisions is different, but let me first talk about this normal one, which is similar to multiplication. For multiplication, like we see here now, I'm having a table, which is y. Y is given, this was a repeat. Okay, yeah. Y is given in meters, x is in centimeters. Now, because you see, I'm going to divide an x and y. I can only divide the two terms if like, especially if they are all length. I can only divide them or multiply them if they are in the same unit. That is also another technique you should know. You cannot, if you're dividing length, then make sure they are in the same unit. If you cannot start dividing a centimeter with a meter or a meter with a centimeter. Either all of them must be in centimeters or all of them must be in meters. That is why you see in the table of results by default, since x was in centimeters, we needed to change this x to meters. But I want to talk about multiplication first. Now, I'm going to multiply f x. Now, if you have a look at those tables that that we shared, the tables, if you look at table 3, we have put in there in brackets, take f to be equal to 0.200 meters. I forgot to indicate it here. F was given as 0.200 meters. Now I'm going to multiply 0.2 with the x. But the x is in centimeters, so you'll use the x which is here in meters. Now, before you talk this, now it has pushed me to come back to x. For me to change x in meters, we all know we divide. If I'm changing from centimeter to meter, I will divide by 100. We all know that. I'll divide by 100. Now, since I'm dividing by 100, I will come and look at between these numbers here. I'm now telling you the simplest way you'll do it. Look between the numbers lined here, the ones I'm trying to change. Which one is the biggest? That the biggest is 61. That is the one I will start with. Now, 61, if I divide it by 100, it gives me a 0.61. Let me first get a pen here so that I can track. I'll have here a 0.610. That is when I divide my 61.0 divided by 100. But when I divide it, I need to as well take note when we are dividing, when we are multiplying or dividing, we follow significant figures. Remember, in addition and subtraction, we follow the decimal places, and it was decimal places of the leading line. Now, in multiplication and division, we follow significant figures. Now, let me hope we have knowledge about what significant figures are. If not, maybe the people will raise the questions, or probably our teachers will help us, give us the hints there in our respective schools. So I'm following significant figures because I'm going to do division. Since this, I'm changing it to meters, so I'm dividing. I have to divide everything by 100. That is division. So I need to follow significant figures. I will come and look at the biggest value, which is 61. I look at it. This number is having how many significant figures? It is having 1, 6 is a significant figure. This one is a significant figure, and this 0 is a significant figure. So these are 3 significant figures. Now, it means when I divide, my answer should also have 3 significant figures. Now, when I divided by 100, my answer was 0.610. I will come and check, is it having 3 significant figures? 6, this 0 here is not significant because this is what we call the leading 0. It is in front of other numbers. It is coming before other numbers, the non-zero numbers, because our first non-zero number is a 6. Now, this 0, this side there is no number, which is not a 0. So it makes it not significant. Now, this 6 is significant, this one is significant, and this 0 is also significant because it is coming after a number which is not a 0. Now, these will be 3 significant figures, meaning my answer is now okay. Because the answer I'm supposed to write is supposed to carry the same number of significant figures as the significant figures of the mother here. This is now the mother. Now this is the child. It's also supposed to have the same number of significant figures. But when I look at this child I have developed, is now having 3 decimal places. As a result of having as a result of having 3 DPs, three significant figures, he as well developed 3 decimal places. Now, that means the rest of these, I have to write them and give them 3 decimal places. The rest of this column, I will be writing it with 3 decimal places. Take note, the first value, for me to get the first answer, I checked the biggest here, which was 61. I divided it, and then I wrote my answer having the same number of significant figures as this. Now, it is after writing the answer that I have determined the number of DPs in that answer. They are the same number of DPs I will use in this entire column. So meaning the column of X in meters will be having 3 DPs. So meaning this one, this first one, meaning it will be a 0.251. That will be now my first value. That will be my value here. And the rest will also go on following like that. This will be a 0.300. So that it gets 3 DPs. This will be 0.370. So it will also have 3 DPs like that. Now, that is how you have sorted that column. Now, that is the unique thing about when I'm dividing a number by a float or a number which is constant. We were dividing, everything here was being divided by 100, 100, 100, 100. Now, when I'm going to my fx, remember we said our f was equal to 0 0.200. That was our f. That is the f we are given on that table, that we assume f is that. Now, for me to multiply, like we said, similar to division, I will follow the significant figures, meaning I'm going to be multiplying this. I'm going to be multiplying this f here with every value of x. But since f was in meters, so you'll be multiplying with the x, which is also in meters. I cannot multiply a meter with a centimeter. So you'll multiply it with the meters here. Now, I will have to check and see. When I multiply this f with the first value here on the top, and when I multiply this f with the last value, which one gives me the biggest answer? Now, let's see if we multiply 0.200. I multiply it with 0.2. I multiply it with this one, 251. The answer gives me a 0.0502. That is the answer I'm having. Let me take note of it here so that people can follow clearly. When I multiplied this with this, I got a 0.02. I mean, sorry. 0.0. 0.0502. 502. That was the answer I got. Then I will also test and see when I multiply that 0.02, that is 0.200, and I multiply it with my value, which is down here, is 0.610. What is the answer I get? I realize that the answer I get is 0.122. That is the answer I'm getting when I multiply. This f here, and I multiply it with this first value, I'll get this. When I multiply it with this last value, I'll get this. Now, my role is to check and see between this first answer and this last answer, which one is the biggest. I realize all of us, we agree this is the biggest answer. This is bigger than this. 0.122 is bigger than 0.05. Now, what does it do now? It means this now has no use to me now. That one, it will now have no use. Remember, for you as a candidate, when you're doing, you're not writing it in here. Me, I'm writing it because we are not together. So I want to put it there so that we can track together. Now, after I have established the biggest answer, now I will need to write that answer respecting the significant figures of these two people I'm trying to marry. I'm marrying a 0.200 with a 0.610. 0.200 is having 1, 2, 3 significant figures. 0.610 is having 1, 2, 3 significant figures. So implying that my answer, I should rate it with the smallest number of significant figures between these two. Similar to what we did with addition, but only that addition we're looking at DPs. Here you look at significant figures. If this one is having 3 significant figures and this one is having 3 significant figures, then my answer should have 3 significant figures. If this one maybe had 4 significant figures and this, what's not happening?
Sorry.
You stopped, you disabled me. Okay, so I was saying if this value is having 4, for example, if it had 4 significant figures and this value also had 2 significant figures, then This is having 2 significant figures. This is having 4 significant figures. My answer should have 2 significant figures. I take the least number of, like I said, the boss will always take the least between the two I'm trying to marry. Now, that is how we do it. Remember, the step is you first multiply, you check. If I multiply with the first and the last, which one gives me the biggest answer? You realize when I multiply with the first and the last, the answer I get it when I multiply here. Now you pick that answer. That answer, I'm supposed to write it having the same number of significant figures as the least number of significant figures between these two. But now, since for our case here, this is having 1, 2, 3, and this is also having 1, 2, 3, then our answer should also have 3 significant figures, which is a 0.122. Now, like we said, after getting the boss, the rest just obey what the boss has said. This boss here we have gotten is having now 3 decimal places. Hope members are following how we are switching. After we've switched from significant figures, it has helped us to get the biggest answer, and I've written that biggest answer to the respectable number of significant figures. Now that boss now, that is why we'll stop talking about significant figures. The rest will not be following the number of DPs of this man here. If he's having 3 DPs, then the rest should also have 3 DPs. Therefore, if I multiply a 0.200, I multiply it with a 0.251, the answer becomes a 0.0502, which is having 4 decimal places, but it has to respect what the boss is saying. So I write that answer to 3 decimal places, implying that our first value will be, this value now will become 0.5, sorry, there is a 0.5. It will be a 0.050. Now I will drop a 2 because a 2 cannot be rounded up. I would have rounded it up so that I have here, for me to maintain a 3 decimal places. So a 2 cannot be rounded up. If I multiply a 0.2 with a 0.300, it will give me a 0. From the calculator, it is giving you a 0.06. That is what the calculator is giving you, I guess. But now remember, this answer I'm writing is supposed to respect the boss. So I'll need to make it 3 decimal places. So you'll have to add here another 0. That it becomes 3 decimal places. And I continue doing the same for all the multiplications until I fill this column. So that is how we do multiplication in the table of results. We follow significant figures, fix the biggest answer, and then finally I use the decimal places of the biggest answer, fix the decimal places in that entire column. When I look at division, I'm having x divided by y. Now this is now another normal division. I have looked at the division of dividing by a float number or a number which is a constant number. Now I'm looking at division which is normal. I'm dividing 2 numbers which are changing. I'm having this x is changing. X is changing. X now, the x I'm talking about is the one which is in meters. The x is changing and the y is also changing. So what do? We do the same thing like I did when I was getting this fx here. I will divide this first x, divide it by y. When I divide it, I'm having a 0.251, this 0.251, dividing it by 0.05. It gives me an answer of 5.02. So I'm having an answer of 5.02. That is the answer I'm getting. Now, I will again divide. I will now again jump at the bottom. Remember my process. I check up, then I check bottom. I'm trying to look which one is giving me the biggest answer. So I'll now divide by this. I divide the 0.6, 0.610. I divide it by 0.610. 0.610. I divide it by 0.610. I divide it by 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610. 0.610 divide it by, I divide it by this y here, 0.30. The answer it gives me is 2.0333. Now that is the answer it is giving me. It is giving a 2.033 recurring. Let me be stopping there. Now, my purpose is I always look for the big answer. We shall all agree this answer here is bigger than this. So implying this answer has become now useless. Or at this moment, what I'm going to do, I don't need it. So for you as a candidate, you will not be doing them in the table here. You'll be doing it on your calculator direct. You check here, you know the answer, you see the answer you have got, you check here, you see the answer you have got, then you can be able to tell which one is giving you the biggest. So since it is this line, which is giving us the biggest answer, now you'll get this, divide it by this. Remember, I'm considering significant figures since it is division. I look at the two numbers I'm dividing. This number here is having one. This number is having 1, 2, 3 significant figures. And this number here is having a 0. This is 0 is not significant. This is not significant. This is one significant figure. Okay. Now, it means that I'm dividing 3 significant figures with a 1 significant figure. So my answer should have 1 significant figure. Now, if I look at the answer I have and I change it to 1 significant figure, it means I need only to take this number as a significant figure. So I have to round it up to 0 decimal places to round it up. If I write only one significant figure, it will just be a 5 with no decimal point. Now, once I've written it as a 5, I will realize that the boss now has appeared. This boss is having how many decimal points? Is having 0. It implies the rest here should follow what the boss has said. Now let us test it and see what are the rest having. If we divide a 0.3, we divide it with a 0.1, because we are dividing a 0.3 with a 0.1, we shall have here a 3. If we divide a 0.37, 0 divided by 0.15, we shall have an answer of a 2.466, which is supposed to be a 2. I know this was 0.440. 0.522. These were our values. Now, if I also divide the 0.44, if I also divide the 0.44, I divide it with a 0.20. 0.44, I divide it with a 0.20. I'll have my answer is also 2.2, of which when you round it up, it gives also a 2. When we are doing a practical, and this is how our results are appearing now, we are tending to have a repeated value. Now here we shall drop following the boss. Now what do we do when we drop? We stop following the boss. The moment when I'm following the boss, I realize that it is leading me to having a repeated value. Then what I do is I increase the accuracy of these values. Now, since they were having 0 DPs, I'll now increase to 1 DP, meaning I'll go back and visit my first value. If it was 0.25, 0.251 divided by 0.05, now it gives me a 5. 0.251, I divide it by 0.05. It gives me a 5.02. So you'll increase it to a 1 DP. I want to see if I will eliminate the changing these repeating values. That is why we increase by 1 DP. If I was recording to 1 DP and I get a value which is repeating itself, then I will increase 2 DPs. So now we'll check this one, 0.3, 0.300 divided by 0.10. It is a 3.0, it is a 3. So I'll give it also a 1 dp. If I look at 0.370, I divide it by 0.15. I'm dividing this now, x divided by y. It gives me a 2.4666. So if I rate it to 1 dp, I will round it up to 1 dp, which gives me a 2.5. And if I look at this one, this one now, 0.440 divided by 0.20 will give me a 2.2. Then if I look at this one, which is a 0.522, I divide it by 0.25. The answer you'll have, if I round it up to 1 dp, the answer I'm having is 2.088. So if I round it up to 1 dp, is 2.1, because I round up the 88. So it becomes 2.1. And if I look at this one now, 0.610 divided by 0.3, the answer is 2.033, which means if I rate it to 1 dp, it will be a 2.0. Now I will have solved the problem of repeating values. Otherwise, had I continued following what the boss was saying, I would have ended up having here all these answers 2, 2, 2. So to avoid that in a practical, when we realize the problem is coming up like that, I will slightly increase the number of DPs. If I had 0 DPs, I'll now change and rate my values to 1 DP. If I was rating them in 1 DP and I'm getting certain values repeating themselves, I'll now increase, start using 2 DPs. So that is how we do the multiplication. And even when you look at this, fx divided by y, same thing is supposed to be followed, this division here. I'll come and see, because fx is here now. Fx is now here, and it is being divided by y. Y is here. Now we'll come and test and see between this value, when I divide it with y, it gives me what? I'm having 0.050. I'm dividing it with 0.05. I'm dividing 0.050 divided by this. The answer is 1. I'm getting a 1. Then I will come also and check this one below at the bottom here. A 0.122. I'll divide it with 0.30, this one here. And the answer I'm getting is a 0.40 something. So I will automatically see that the one up here is giving me the big answer. So it is the one I will start with. And when I'm dividing, it is 0.50, and I'm dividing it with 0.05, which is giving me a 1. Now I need to look at the significant figures. These are how many significant figures here. This is not a significant figure. This is not a significant figure. This is significant. This is significant. So these are 2 significant figures. I'm dividing them by what? This is not, this is not, this is a significant figure. So there is only 1. I'm dividing 2 significant figures with 1 significant figure. So my answer should have 1 significant figure. So when I divided, I got the answer as 1. So meaning I need to record my answer as 1. Now, I want, of course, we want to see if we shall still have the same case. Now here I'm having 1. Now this one here I've gotten, who is the boss, is now having no DPs, meaning the rest here shouldn't give them DPs. But if we check, we can check and see. Now if I'm doing 0.06 and I'm dividing it with, I'm dividing 0.06, dividing it with 0.10, the answer is 0.6. Now if I round it up to 0 DPs, it will also give me a 1 because it is 0.6, meaning I'm already having a problem of what? Of repeated values. So what do? I increase by 1 DPs like we've just looked at here. Now I stop following what the boss is saying. I now disobey the boss. I will increase the DPs so that I eliminate this. Now, if I increase the DPs, it means this first value, which I divided, since it was 1, to record it to 1 DP, you need to add there a 0.0. Now, this second value I have done, to record it to 1 DP, the answer was 0.6. So it will be 0, I record it as 0.6. If I check the third value, I have not done it. Let me see, fx, 0.200 times 0.370. This is 0.074. Now, if I divide this answer, this 0.074, I divide it with the 0.074, I divide it with 0.15. The answer I get is a 0.49, which I round to 1 DP, will be a 0.5. 0.5. And you'll go on doing the same thing until you finish the whole column. Suppose you reach a point here and you realize that maybe a certain value I'm having here is repeating itself here, then you do the same thing. You will again increase everything by 1 DP, meaning you have to go back and recompute using now 2 DPs. That is what now you do. So quickly, that is what I can share about data manipulation when you're using division, multiplication in the table of results, or addition and subtraction. I had not talked about reciprocals. With reciprocals, we follow the same principle as this one here, what we've done for these values, which were the float. Maybe let me look at the scales, which are going to bring me to an example which involve reciprocals. Eric has raised their hand. Is it okay if I can hear from you? Eric?
Yeah, okay. What I'm asking, I don't know if I can ask it now.
Is it concerning what I've just talked about?
Exactly. That's why I want to bring about it. You see at a point where you're having the quotient x over y.
Yes, here.
Assuming in our table here, we had the column of 1 over y, yeah?
That is not the reciprocal.
Yes, and somebody deliberately takes an option of getting 1 over y times x to obtain this quotient, and that one who has done direct x over y. Do we consider the 2 scenarios to be right, or we consider only one?
You said maybe we have, this was 1 over y.
Yeah, I have y. Now take an assumption I have 1 over y in this column, in this table. Now, in the due course of looking for x over y, I just get x times 1 over y. I just use those parameters. Do I end up the same point of values that I'm getting as far as manipulation is concerned?
I had not checked it, but I believe it should lead to the same thing, because I believe that y was there is a way it was uniform somewhere.
Actually, what we can do, just get 1 over y of these values of y that you're having for the first one and the last one, then you will see the implication of what it brings.
Okay, let me check. This is 1 over y. Now, when we are dealing with reciprocals, let me say if I'm going to get 1 out of y, I will come and check between these values of y, which one is the biggest? That the biggest is 0.3. So that is the one I will deal with. If this is my 1 out of y. Now you come and check the biggest value, meaning I'm going to take 1 divided by 0.30. Now when I say 1 divided by 0.30, it becomes 3.333 recurring. But now my answer I'm going to write should have the same number of significant figures as the mother. Now this 0.300 is having 2 significant figures. So if I write my answer to 2 significant figures, it will be a 3.3, because that is how it will have 2 significant figures. So it will be a 3.3, meaning the rest of this column of 1 over y will be 1 dp. Now, if I check the first value, 1 divided by 0, 1 divided by 0.05, it is giving me a 20. So meaning this value here will be a 20.0, because the boss has said that we use 1 decimal place. So this will be 20.0. Now it was Yahoo, I've forgotten the name. Said we can examine it and see. Now, suppose this student was going
Eric.
to use, yes, Eric.
Yes.
Eric, now suppose the student is now going to use this times the x instead of x divided by this. Let's see. Our rules of multiplication remain. I have to check between this value, the first value, between the first value and the last value, which one is giving me the biggest answer if I multiply it with x. So if I check the first value, 20.0 times 0.251 gives me a 5.02.
5.
Yes, a 5.025, right? A 5.02. Yeah. It gives me a 5.02. Then when I multiply, I multiply the bottom one, 3.3, I multiply it with the 0.610. It gives me a 2.013. So meaning the biggest answer is up. All right? Isn't it?
Yes.
Now, if I look at my biggest answer up, I will come and check. I will come and check and see, following the rules of manipulation. It was 0.251 times 20.0, giving me a 5.02, meaning these are 3 significant figures. These are 3 significant figures. Then I should write my answer to 3 significant figures, which means now I need to add here now the 2. Now we realize if I do that, it is now giving me a 2 here. So we need to obey this rule, because this was 20.0, this was 0.251, which is 3 dps. I mean 3 significant figures, 3 significant figures, giving me an answer of 3 significant figures. Now this answer generates 2 dps. Now we've all realized that this answer now means it will change what is happening in this column, meaning this column is going to be for 2 dps. Now that implies when you are told to use x divided by y, you're supposed to use x divided by y, not 1 out of y times x, because that will change the meaning of the question. Because we've seen when you use that, it changes the accuracy of the outcome. Have I answered your question, Mr. Eric?
Yeah.
Okay. So that is basically about the tables of results. I want to quickly talk about how we get scales. We know, or those who don't know, the convenient scales are the 1s, the 2s, and the 5s. I know in the middle here, there is a 2.5, which is also regarded as convenient, but we tend to emphasize this. Reason they are called convenient, like we all know the word convenient. Something that doesn't take a lot of effort, something that gives you peace. We want a student, a candidate, to use scales that we can easily read, that the examiner will be able to easily read. You can easily read your coding, you can easily tell your plotting. That is why they are called convenient scales. And these are the scales that you are expected to use. Now, remember, when you don't use them, does not mean it is the end of the world, that you're going to die. No. But what will happen is you'll miss the marks for the scale because the scale is awarded its own mark. I will show you now some on the sample of a graph paper. Now these are the convenience scales, meaning the values you have on a given axis should be lying in any of these scales. They may be of 1 dp, meaning they may be lying in n of this or n of this. For us to understand it better, you need to look at an example. Let's consider table 5. Those of us who have forgotten, or if you can refer to table 5, if you look at that table 5, it looked like this. Had x here in centimeters, v given to you, and the I given to you. It required you to have 1 out of x and then to have v out of I. When I was telling you, if you look at in the tables we've given you, we've not even indicated for you units here. So we expect you to have completed them by awarding them the appropriate units. Okay, they are putting there the appropriate units. So you'll fill and complete those tables, and then you consult with your teacher to see if they are right, if you've completed them well. Now, if we look at how we completed our 1 out of x, for example, we want to get 1 divided by this. So we need to look between these numbers here. Which one is the biggest? The biggest was 42. And when we divide 1 divided by 42, you'll get 1 divided by 42, you'll get a 0.02380 and so on. But now the number I'm having is having 2 significant figures. So my answer should also have 2 significant figures. That is why I have to write 0.02, meaning the next significant figure I'm supposed to stop at is a 3. But since there is an 8 behind it, I have to round it up. So it will be a 0.024. So that the answer is having 2 significant figures. But when now I write it 2 significant figures, it ends up generating for me 3 decimal places. 1, 2, 3 dp. Meaning the rest of this column, I will write it to 3 decimal places, as we can see. V out of I, we did the same. We test. This is my V, this is my I. I will check and see this number divided by this. What is the answer I get? 0.5 divided by 0.4, I will get a 1.25. When I divide this one below, 1.0 divided by 0.2, 1 divided by 0.0 divided by 0.2, I will get a 5, meaning this is the biggest answer. Now, I'm dividing 3 significant figures. This is 1, 2, 3 significant figures. I'm dividing them with 1, 2 significant figures. Remember, these leading zeros are not significant. So it means 3 significant figures divided by 2 significant figures, my answer should have 2 significant figures. That is why the answer was 5. But for me to make it 2 significant figures, I need to add there a 0.0. Now, when I add a 0.0, they become 2 significant figures. They automatically as well generate a 1 dp. Implies the rest of this column, I'll give it 1 dp. Now, that was just a recap. Now, I want to look at how I can get a scale of this. Maybe in the case in the question, they are telling me to plot a graph of V over I against 1 out of x. Now, for me to get to the scale, we know I will consider the highest value. I subtract it from the lowest value. Then I divide by the number of big boxes. Now, the number of big boxes, let me first show you the number of big boxes I'm talking about. If we look at this graph, I don't know if it will be clear wherever you're looking at. Big boxes, we are meaning these 2 centimeters combined. That is what we call a big box. Those are the ones we call a big box. Now, if I'm going to get my scale on the vertical, I will first of all come and look at my graph paper. And I see how many big boxes do I want to use vertically here. If I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I say I want to use 10 big boxes. I want to write and stop here at the 10 big box. Or what I can translate as at the 20th centimeter, since I'm combining each big box is containing 2 centimeters. So these 10 big boxes will be the ones I'm going to divide with my what? I will be the ones that I will divide with my number. Now, like I see, if you look at my table, I need to keep referring to this table. To look at this table, V over I, the smallest number is 1.3, the biggest is 5.0. So meaning that that is the number. I'm going to say 5.0 minus 1.3. I divide it by the number of the big boxes I've chosen. Now the answer I get gives me a 0.37. Now this number here I have gotten, I will come and see where does it lie amongst the convenient scale. I see it is a number which is just a 0.3, a number is coming immediately after a point. So I come and look at among my convenient scale, because in scales of 1, it can be a 0.1, 0.01, 0.00, or it can increase like that. 2 can decrease or increase. 5 decrease, increase like that, as long as they are multiples of 2. So I look for this number 0.3, since it is a number immediately after a point, I'll come and see along the line of numbers that are immediately after a point is this line here. Now this number 0.3 is bigger than 0.1. It is bigger than 0.2, but it is less than 0.5. So meaning it is in between here. So instead of me choosing the number which is small, which instead of using a scale of 0.2, I will instead choose the number that is slightly higher than the value I've gotten, which is a 0.5. So that will be my scale. Meaning on the vertical axis, I'm going to use a scale of 0.5. My numbers will be increasing in steps of 0.5. Since the smallest number was a 1.3, now the number you'll start with on that scale, like I will show you on the graph, should be also a multiple of my scale, okay? The scale is of 5, because 0.5 lies in 5. It should be a multiple of that number I'm going to start with. So I cannot start with 1.3. Instead, I will opt for a 1.0. Then meaning the next number you'll have, or you'll add there the scale I've chosen, which is 0.5. It will be 1.0, then 1.5, then 2.0, 2.5, like that. So my scale will be of 0.5, which is the convenient scale vertically. If I look at the horizontal, for the 1 out of x, we realize that the highest value in that line, it was the 0.100, and the smallest value was 0.024 in that column of 1 out of x. So I'll get the highest value, I subtract the smallest value from it, then I divide by the number of big squares I want to use horizontally. Now these are the ones I'm talking about. If you look at this, I'll come and see horizontally, how many big squares do I want to use? I can say, okay, I'm going to use 1, 2, 3, 4, 5, 6, 7, 8. I want to write and stop here. Now I've chosen 8 big squares. So those will be the ones I will choose to use on the horizontal. Now they'll be the ones I will divide here. Now when I divide them, I get an answer which is a 0.0095. Now I will come and look for this number. Where does it lie? I realize it is a number. It lies where I have 2 zeros after the decimal place before I get a non-zero number. Now, meaning I'm looking at this line where I'm having 2 zeros after the decimal place. But when I check there, I realize that 0.9 is bigger than 1. It is bigger than 2. It is also bigger than 5. So meaning, because once I go beyond this, meaning I'm going to the next line, which is bigger than this. Now it means my value is lying around here beyond 0.005. So I cannot choose this now. I will choose for the number which is bigger than it, which is now I will go now to the next line, which is a 0.01. Okay, that is how I will have chosen my convenient scale horizontally. Now I will go, I have now known my convenient scales. I have known that vertically I need to use a 0.5, whereas horizontally I need to use a 0.01. I will come and draw my axes. Now, as I combine this all together, when you're drawing your graph, make sure your title. I wish I could zoom in here. Does it even give me an alternative of zooming? I don't know. Mr. Kazeba, I don't know, is it clear on your screen? Is the graph somehow clear?
Yes, it is clear.
Okay. Now, when you're doing a graph, every rating, now this is important point for you candidates. Everything you're going to write on the graph should be on this green part here you see on the graph. You see the graph is having the green part is ending here. Then there is this white part. Even if the white part is up there, even on this side and even bottom. Now, take note that everything you're going to write on the graph paper should be on this green part. That is why you see, even the title, I have written it on the green part. So right here, a graph of V out of I against 1 out of X. As this is a free mark that I expect every candidate to get, sincerely. Because in the question paper, they will always tell you, plot a graph of V out of I against 1 out of X. In other words, they've given you what to write here. So just always copy it and indicate it here. Take note, don't include the units of V out of I in the title, and even 1 out of X. Don't include units in the title. Then, when you start drawing your axes, draw them so that they meet perpendicular to each other. In other words, if you've chosen to draw them in this line, let this axis remain in that line. Use a straight ruler that it remains in that line, and even this axis remains in that line. Then make sure the arrow, now here I need your attention, candidates. These arrows here on the axis should be touching this last line here of the green part, similar to this one here, vertical. The arrow should be touching the last line. Then you indicate the quantity. Now here, when you're labeling the axis, you now have to bring the unit of that quantity. If in the table you had it as V over I, you were using maybe volt per ampere, then you put here the unit in the bracket. And if 1 out of X was per centimeter, you put it also here in the bracket. Take note, everything I'm writing it on the green. Therefore, as you're budgeting, as you're counting the centimeters you're going to use, leave some space where you'll do your writing. On the left here and on the bottom, leave there some space where you'll do the writing, so that you don't miss marks for that. Remember, on my axis now, I will start demarcating my axis. I'll demarcate every big centimeter. Demarcating, it means I'll put these lines, these small lines here, which indicate for me that I'm going to write here, I'm going to write here, I'm going to write here, like that. That is demarcating. And write a starting point of each scale. Some candidates have a habit of maybe all scales were by accidentally starting from 0. Now they come here and write a single 0. Please, that is not allowed. If every scale is starting from 0, then write here 0 and continue. Also write here 0 and continue. So each scale should have its starting point. Then now, like, remember, my vertical scale was a 0.5. So, and my smallest value in this column of V out of I was 1.3. I've decided to drop a 0.3. I start with a 1.0, which is a multiple of the scale I'm using. So I'll start with 1.0. I add there my scale, which was a 0.5, which will give me a 1.5. I add there the scale, which will be 2.0, 2.5, 3.0, 3.5, 4.0, 4.5, 5.0, 5.5, 6.0. And then I know that I will have covered all the values. Because the smallest value was 1.3, I will be able to cover it. It is in between here. The biggest value was 5. I think it was 5.0. So I will also have gotten it here. Okay. So that is how you can indicate your scale on the axis. Similar to the horizontal. Now the horizontal, remember my scale was a 0. I said I will use the scale of, it was what? A 0.01. But the smallest value was 0.024. So I can decide to start with a 0.020. Now, when I decide to use that, meaning when I start with a 0.020, then I add my scale of 0.01, it will become 0.03. The next one will be 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, 0.10, and I even have some space here remaining. And you will realize that I will have catered for all the values, because if the smallest value was 0.024 and the biggest is 0.10, then I will have catered for all of them. If you look at my graph, I will have created the 0.024 will be lying in here, and the 0.10 is here. I'm able to plot all of them. I can see Eric's hand is up.
Eric, can you mute?
Yeah, I'm on now.
Mm.
Thanks once again. Now the issue is on, you see, after choosing our convenience scale, yeah? Assuming my convenience scale was, I chose, let me say, a 0.1, okay? But the values that I'm going to plot in my table are to two decimal places. Let me say 0. Let me say 2 something, 0. What? Now, if I'm writing these values that we have written on our graph, do I write to one decimal place like 0.1 of the convenience scale, or I'll write in respect to the one who's in the table like 0.10? I don't know if you get what I'm asking there.
Oh, you're trying to mean if like I've written here, right? Like this is 0.02. Huh?
Actually, let's use the vertical axis very well. It can show
this
us
is
what
1.0, this is 1.5, right?
Assuming my convenience scale is, let me say, 0.1, okay?
0.1.
Yes, but my values in the table are two decimal places. Let me say 0.2 something, you get it, something of that sort. So when I'm writing these values that I'm writing here on the scale, do I put the convenience scale with two decimal places in respect of what I have in the table, or I will just set 0.1 strictly? Just that.
Okay, thank you so much, Eric. Now, when I'm writing on the table of results, the table of results, I mean, sorry. When I'm writing on the graph, yes, the graph is not, there is a way I disconnect the graph now from the table of results. Now this is going to be fun.
Yeah.
A graph, the moment you do a graph becomes an independent measuring instrument. The moment you do a graph like this, it has become an independent measuring instrument. Meaning, I may even be having my values in the table of results at 3 dPs. But my graph here, the smallest it can measure can even beat 2 dPs. Let me hope you're getting my idea. For example, if we look at this, we treat this now as a measuring instrument. Vertically here, the smallest it can measure, what is what? Remember, the interval is 0.5, 0.5, 0.5. How many divisions are in 0.5? They are 10. So meaning each small one is 0.05.
0.05.
Right? So that means even in my graph, in my table of results, I might have been having values which are 3 dPs. But here my graph is having, the smallest is measuring 2 dPs, 0.05, which are 2 dPs. So that has no problem. As long as you have followed this rule here. Like a quick example, no, this was coincidental. I think it catered for both of them. But if we had enough time, we would have looked at another example. But if you look at these are 3 dPs, whereas my convenience scale is 2 dPs. But if you look at my graph, it is by default changing also to 3 dPs. Because the smallest, if this from here to is 0.01, from here to is 0.01. So 0.01, when you divide it by these 10, it gives me a 0.001. So it means it is recording here still 3 dPs. So to answer your question, in simple terms, is that it is not a must that your graph should have the same number of dPs with your table, with the values you have in the table of results.
But I should respect the smallest.
The smallest, what do you mean,
the smallest division, like how we have, 0.1, the smallest now I divide by certain, so I respect the smallest.
Like now you realize once I move from the table of results and I've come to the graph, the biggest part of the table of results is going to end here, because the moment I'm able to plot all the values that I had in the table of results, meaning the table of the results was able to communicate with the graph. Now, starting from here onwards, I'm now starting a new chapter. There I will be now going to look at things like scale, like slope, sorry. And when you look at slope, The slope, I rate my values depending, I use the accuracy of what is on the graph. If vertically, it has 2 dPs, then also my change in y will be having 2 dPs. Y1 will be having 2 dPs, Y2 will be having 2 dPs out of. If here it is having 3 dPs, then also my change in x will be having 3 dPs. So my x1 will be having 3 dPs, my x2 will be having 3 dPs. Even if when I was taking my slope, the x2 was here at 0.03, because this is not behaving like a measuring instrument, I will not rate it as 0.03. No, I'll have to say 0.030. So that it follows what this graph paper is saying.
Exactly.
Yeah.
Yes.
So basically, thank you so much, Eric, for your contribution. So that is how we can look at the graph. I will not go so much into the plotting. Maybe what I can talk about the plotting is to make sure you use, we have many symbols that are allowed that you can use. One of them, you can use a dot, like you see I've plotted here, a dot in the middle with a small circle around it. The other one you can use is just using like an X, like a small X to mark that point. Or you can use a small cross to mark that point. Now, those are, I've so far given you 3 different symbols you can use to plot. Or you can even use a dot. Now, the problem of using only a dot is when you draw a line of the best fit, that dot may not be seen easily. And someone may deny you a mark for not plotting a certain point. So it is more safe to use this, a dot with a small circle around it. Make sure your circle is not going beyond a half of a square. If you look at the circles I've used here, it's just, I'm plotting a circle, a dot, I'm putting a dot in like a cross, a small cross, then the other circle is just cutting half of each squares on the sides. So make sure your circle is small. I've already talked about how we can get our slope. Rate your slope. Some candidates still have a tendency of doing it this way. The rate here slope is equal to change in y over change in x. But now if I come back at the graph paper and I ask you, where is y here? There is no y axis. There is no x axis. The axis I'm having is v out of I, is the axis here. And then 1 out of x is the axis here horizontally. So that is the same way you should rate your slope. Use slope is equal to change in the unit which is on the vertical axis out of change in the unit which is in the horizontal axis. I've added this to show you how you generate the unit of the slope. What is up had this unit. What is down had this unit. This was its unit. Now I can put it here on the side to track what is the unit, or what is going to be the unit of my slope. Now, ohm out of centimeter, this centimeter, since it is having a -1, it means for me to remove the negative, I need now to take it up. Remember, candidate, if I have a number here up, it is having a negative power. For me to remove that negative power, I need to take that number down. The moment I take it down, the negative power will disappear automatically. But now, since now it is having a negative power and it is here down, now for me to remove this negative power, I need to take this now thing up. The negative power will disappear. So that's what we've done here. But those who know the rules of indices, they know how to play with it here quickly. And you know, of course, it will become ohm, and then the centimeter will have also gone up. So the unit of the slope will be this. Then when we look at here, I've mentioned for you that the vertical values have 2 dPs. This is what Eric led us to, whereby if I look at my slope, if I draw my line of the best fit, and I'm going to take a slope, the value I'm going to read should be having 2 dPs. Why? I remind you once again, this graph paper is acting as a measuring instrument now. So you look at the smallest it can measure. If you look at the smallest it can measure, this small division is 0.05. Now, the smallest is having 2 decimal places. Therefore, all values I will read here vertically, they will be up to 2 decimal places. That's why you see I've written this thing here. They should be 2 dps because that is what my graph dictates. If your graph here had maybe the smallest was 1 dp, then I expect your vertical values all to be having 1 dp. If I look at my horizontal values, it is having the smallest it can measure is 0.001. That is each division here is 0.001, which means those are 3 decimal places, implying that all values I will read that are coming from this axis here, they should be having 3 decimal places. So that's why I recorded for you this here. So that is briefly what I can share. I tried to race with the time, but it is not easy. I hope I've tried to touch what is the most important. I can see Eric's hand is up again. I think I'm now going into a session of allowing or welcoming some queries or questions. Is it okay, Mr. Kaziba? Mr. Kaziba, you're off, but I think I can quickly be taking some of them. Let me first have Amaku Robert. Amaku Robert, unmute.
Okay. Are you getting me?
Yes, I can hear you.
Yeah, I only wanted to know one thing, whether you can organize seminar again. So interesting.
Whether?
You can organize that seminar again, and when it will be, it is very interesting.
I'm not hearing, sir.
Are you not getting me here?
Yes, you said you
No.
Whether we can organize what?
That seminar again.
This seminar again?
That seminar, yes.
The staff?
Hello.
Mr. Kaziba, can you hear him? Hello, Mr. Amaku.
I am saying, is there a possibility of organizing
such a seminar again, eh?
Yes.
Oh, yes. I think the seminars will be continuous. Mr. Kaziba will respond to that.
I'm saying, is there a possibility?
Two?
Okay.
The microphone was a bit low, but I think the query was about organizing. I don't know if it was more of this kind of seminars or what. I think that will be answered if Mr. Kaziba comes on. Eric, you've come in again.
Yeah. Now, I'll take you back from the beginning. Okay, not from the beginning of this, but when we are starting the practical. There is this given information. For example, let me say, for example, I've been given mass in kilograms. Yeah. This mass is in kilograms. Okay, we know to the normal standard it is 3 decimal places, right?
The mass in kilograms, eh?
Yes.
But
now, by some coincidence, because I've seen this several times, also in the exams, if they gave you that mass, those values to 2 decimal places, say 0.10, 0.25, they are not including that class decimal place. Now, if maybe I need to compute some force somewhere and I'm going to transfer into my table of results, now I'm taking you back to the treatment of that. Will I consider, will I treat them as 2 decimal places like how they have given me, or for me, I will suddenly now use the 3 decimal places, knowing it is the standard bit of it, because it will affect the continuous manipulation of my results. Yeah.
Okay. Just similar like what I've just shown on this table now. I know if I'm going to use a meter rule, these are supposed to be having 1 decimal place, right?
Yes.
These are supposed to be having 1 decimal place, but they have decided to give them to me without a DP. Similarly, it may be a mass. I think I had another table here. This. Okay. Look at this. This is in meters, and I know in meters, this is supposed to be at least like 3 DPs.
Exactly.
Now, once they've given it to you with the fixed number of DPs, you use the number of, you treat it the way it is given to you. You don't tamper with it. Use it the way it is given to you. That is why we emphasize, even when they've given us a small y, we don't change it to a capital Y. Yes, we know they are both y's, but we don't change it. So thank you so much, Eric.
All right.
I have, is it Chigozi Ernest? Chigozi, you can unmute and ask your question. Chigozi, unmute. Tap on the unmute and then you ask your question. Mr. Kaziba, are you there? Because has gone off. Eric, do you still have something to ask?
Okay, not as such, just that I think I want to black out. Just, I don't know, maybe if we just share the contacts.
My contact.
Yeah, I would share the contact. I don't know.
Are you on the platform for help?
Yes, actually, I'm in that platform.
All right. So we think we are going to put the contact there, sir.
Yeah, I'm in that platform. We shall communicate from there. So,
all right.
Because I'm blacking out. That's the reason. That's why I'm going off.
Okay. Thank you so much for your participation, Eric.
It's all right. It's all right. Thank you.
Yeah. Kasese Muslim. Kasese Muslim, unmute. Okay.
Thank you very much for your presentation. My question is about, why haven't you shown the scale on the graph?
Me writing here, this common thing of scale. I hear vertical is equal to this, horizontal is equal to this. That's what you mean. I don't know. Kasesa, are you still there? You've gone off. Oh, he's gone off, unfortunately. But for those who are online, it is not necessary for me to show it to you on the graph because the scale, I can see it right away here. I can see it here. I don't need to see what you've written for me because what you've written may be different from what you've used. So when you're getting the mark for the scale, you're getting the mark of what you've used here, not what you have written here down. So that is it. Thank you so much. Yes, or travel, I can see your travel. Someone is asking. Yes, you can unmute and ask. Or travel, unmute and ask.
Yes, my question is concerning the scale, the convenience scale for starting to label the axis, concerning like when you gave us the convenience scale for the vertical, for horizontal scale, it was 0.01. Then my problem is from starting to label it on the axis. It's difficult. How do you start labeling it from the axis?
Okay. Thank you so much. Now, when you're going to start labeling, the moment you've known this is your scale, 0.01, this here communicates to you that the numbers I'm going to write will be increasing by 0.01. For example, now I will come and look at the smallest value I have in my table of results. If I look at the smallest value I have in my horizontal scale is 0.024. Now, if remember my scale, remember in your head, the scale is 0.01. Now, if I start with 0.024, I decide to use it as a starting point. The next value is going to be 0.034. The next value will be 0.044. The next value will be 0.054. Now, that tends to create for us what we call redundant values. you realize the 4 which is at the end is not changing. It is remaining constant across all the numbers. So we call that a redundant number, and it can kill your scale, because now if it is moving like that, it is not actually a multiple. It cannot be divisible. You cannot divide it by the scale you're using. Like for example, if you say a 0.024, you divide it with a 0.01, the answer you have will not be a whole number. So that is why we don't, you cannot take this exact value here just as that. You have to make sure that the value you're going to start with can be divisible with the scale you have, and it gives you a whole number. That is 1. 2, that value you're going to start with on your graph, that value you're going to start with on your graph should be either below, it should be slightly below the smallest value you're having in the table of results. Now remember, in our table of results, the smallest value we had was 0.024. Now I will choose to use a 0.02 because first of all, this number here, 0.02 can be divided by 0.01 and I will have a whole number. And again, this number here is less than the smallest number I have in the table of results. So that is how you get the number you're supposed to start with. That number should be able to be divided by the scale you have. And secondly, it should be slightly below, less than the smallest number you have in the table of results. Hope I've answered your question or trouble.
Yeah, okay, thanks.
Welcome. I don't know if we still have some more questions. If not, then I will invite in Mr. Kaziba. I see Twesugomwe Fred. Twesugomwe Fred, unmute.
The issue of intercept. How do we draw a graph yet when we have a procedure that wants us to determine the intercept?
Now, to determine the intercept, we can use okay, this is the graph. Now, to determine the intercept, thank you so much, Twesugomwe. Now, you see, this practical has a lot of things, and exhausting them in this shortest time is very, very difficult. Now, for the intercept, the scale, they are asking me if the graph, the instruction is I get the intercept on the horizontal axis. Maybe they've said find the intercept on one out of x axis. Then this axis here, the opposite axis that they have not talked about, must be starting from 0. Okay? Now you have to make sure that now it means now this changes everything. Now it changes everything starting from where you're getting this scale here. It means now, since you are getting maximum value minus minimum value, now your minimum value will be a 0 because that scale is going to start from 0. Now that is how you will change it if they are asking for the intercept. So if they ask for intercepts on both axes, they ask for intercept on the vertical axis and the horizontal, then both scales are supposed to be starting from 0. But if the intercept asked for is on the vertical axis, then you have to make sure the horizontal axis starts from 0. That is the simplest way I can answer it. Mr. Kaziba, are you there?
Teacher Hewa.
Yes.
Yes, thank you so much. I want to first ask the teacher from Utruba.
Mr. Kaziba,
yes?
A moment.
Okay.
I've just cross-checked in the chat and I see there's some queries like here Chigo's asked at times there are cases where they ask for sources of errors. How can a student identify such errors in experiments? Now here we are looking at the errors. Like you hear, it is source of errors. That where are the possible sources? Where could have in that experiment? Where could have been the possible sources come from? Things that could have made you make an error. Like I can say, for example, a source of errors can be, let's say, for example, presence of wind. Wind can be a source of error, like you will not get the required the proper time because maybe your oscillations were being tampered with by wind. So, are you seeing my battery? Now that is what sources of errors are. Learners are supposed to tell us the possible sources of errors, where these errors could have come from, the errors they think could have made them not to get the required results. Then there's another one. In most cases, oh, where is it? In most cases, it depends on the flow of data. For instance, if the results are increasing and then you get one that is decreasing, that means that there must be an error somewhere. I don't know what it is. For example, 2.6, 2.8, 2.4, 3. For this case, there must be an error. I think this was Uganda Matters High School. I don't know where it is located. They were supplementing that the flow of data is important. It's important that in a table of results, our values are supposed to be flowing in a uniform order. They are either supposed to be increasing or they are supposed to be decreasing. So in a condition where you find that you're having values that are increasing and they reach somewhere they decrease, then that means there is a problem somewhere. You can probably go back and redo the procedures. I think those are some of the concerns I managed to pick from the chat. Mr. Kaziba, you can take on from there. Mr. Kaziba.
Yes. Teacher Hewa.
Yes, please. You can take on. You were saying something.
Okay. Thank you so much, Teacher Hewa, for the wonderful presentation this evening. We cannot thank you enough. We want to thank you so much for educating the nation, for sharing your knowledge. We are really very grateful. However, I'm seeing some hands up. Let me ask Sigome Fred to first make your submission. And also I'm seeing Kasese Muslim, kindly unmute and you first make your comments.
Yes, hello.
Yes, go on.
Thank you very much. For me, I want some emphasis because I joined in late about use of a pen or a pencil
Use of a pen, please. Pencil is not allowed in a practical, physics practical.
Okay. Thank you so much. Yes, Kasese and Mr. Fred. Mary Assumpta. Mary Assumpta, unmute. Yes, Mary Assumpta, go on.
Now my question is, for example, when the values in the table, when you get them and they're all going constant, for example, when you start with 10, comes to 8, then 6, 4, and the 4 remains constant, what do you do?
Those values under a normal practical, we are not supposed to have values remaining constant, except if in that practical, it is going to be like a curve. That is where we expect to have values, but also we don't expect to have more than 2 values being constant. So the moment you see more than 2 values being constant, then probably there could be an error. You can repeat the procedure.
Okay, and then the other one is like, you were talking of areas. Are we supposed to write the areas?
Are you supposed to write the what?
Or the areas which you talked of, which are being caused by wind, maybe those other external areas there. Are we to write those things which caused those areas, for example, the wind and those areas?
If the question was asking about it, then you are supposed to write them down, please.
Okay, thank you.
You're welcome.
Okay, teacher Hewa, before she leaves, kindly make a comment. What if it was the calculated values? Let me say has got to 1 out of X and she's not seeing some trend. Kindly also make a comment on that.
That she's not seeing some trend and then the values were remaining constant. Eh?
No, like I mean, she may calculate 1 out of X and maybe she is getting 0.1, 0.1, 0.1 when she's following the rules.
Hey, like we said now there, when you have a constant value, you increase the number of DPs. If I was having 0.1, 0.1, 0.1, then I will try to increase to 2 DPs now so that I eliminate the repetition of the values.
Great.
Mr. Kazib, I'm going to be joining in using my phone because the laptop is soon blacking out, but you can continue taking questions.
Okay, NVSS. Go on NVSS. Oh, NVSS, we are not getting you. Fred.
So now, how are you fine by that? When you have 0.2 divided by 0.00, how do you record the answer?
0.2 divided by
0.00. How do you record it to two significant figures?
Recording in progress.
You have said 0.2 divided by 0.00. Okay. Teacher Hewa, have you got a question?
Let me first. Unmute me, Mr. Kaziva, on my phone.
Okay. Okay, you can now.
Okay, can you hear me now?
Yes.
Okay, so the question was?
I didn't pick the question, but I had 0.2 divided by.
He said, if, can you repeat your question, please? I was trying to switch now. My laptop has gone down, so I was switching back to phone.
Raise up your hand again, but I had 0.2 something. But let us first pick calcula. Calcula unmute. As Fred unmutes. Calcula.
Yeah, thank you for the great
Yes, Calcula, go on.
That you're giving, but my question is slope of the slope after plotting. Like, is it that the slope has a limit? For example, there is a figure that the slope is not supposed to go beyond that figure, or it's supposed to be below a certain figure.
Can I answer it?
Yes.
Can I go on and answer, Mr. Kaziba?
Yes, go on.
Okay, so about the slope having a limit, now there each slope, you see, when we are doing this practical, we have a purpose of the experiment or the aim of the experiment. In that experiment, maybe you may be trying to look for acceleration due to gravity. Maybe you may be required to get maybe focal length of a lens. Now, the slope, it will depend. What is the use of that slope going to do? If suppose they say that you determine the constant g will be equal to the slope of the graph, and that constant happens to be acceleration due to gravity. The candidates, I think you all know that the acceleration due to gravity is not supposed to be going beyond, we know it is around 10. That is the acceleration due to gravity. So therefore, slope has a certain value which is marked for a given experiment. There is another one where you may find the correct value is supposed to be 0.5. There is another one where you may find the correct value is supposed to be 0.00 something. There's another one where you may find the correct value is supposed to be 1,000. So the slope does not, I cannot say that Okay, to answer your question, yes, there is that slope is expected to be lying in a certain answer, but that answer depends on what the experiment is asking for. I don't know if I've answered her question.
Yes, you have answered it well. Always it depends on the aim of the experiment.
Exactly.
Depends. Okay, thank you. Fred, and maybe to add on, please take note whenever you are drawing that right angled triangle, to check, you must have all your points enclosed within the triangle, the right angled triangle. And whenever you measure the horizontal, let me say the horizontal of your triangle, please ensure that always it is about at least 9 centimeters, and also vertically, it must be about 12 centimeters at least. If at all it is there, then it means you're on track. Yes, Fred?
Thank you for the opportunity, sir. Now our inquiry is that when you have 0.2 divided by 0.002 and you want to record it to one significant figure, how do we do it?
Yes. Now, when you said if I have a 0.2, I'm dividing it with a 0.002, the answer is becoming 100. Thank you so much. Now, we realize that I was dividing a one significant figure with another one significant figure, but the answer now I'm getting is turning out to be beyond one significant figure already. You may say I was dividing it with a 0.025. Let me use, let me say 0.2 divided by 0.00236. That is a good one. 0.2 divided by 0.00236. No. This doesn't give me what I want. Let me say I'm dividing 0.2 divided by 0.0023. The answer we get there, I think it is 86.956 and etc. Now, since I'm dividing one significant figure with two significant figures, meaning that the answer is supposed to be one significant figure, but the answer of one significant figure is already beyond because it is 86 point something. Now here we adopt to taking the minimum number of significant figures I can have without increasing the accuracy. So the minimum means I will write this number to a whole number. I will drop all the points because if I take the points, they will tend to increase more and more significant figures. So I will not drop all the points, meaning I round it up, it will become 87. So for that case, I will keep writing my answers only for numbers. Hope I've answered his question.
Okay, thank you so much. That is very okay. That is very true. However, those are what we call the special cases. Those are special cases, and they are always handled in a special way. And you'll meet such cases, even those are some special cases. Yes. Okay, I think we have exhausted all the questions that we have been having. Okay. Teacher William, first give your concluding remarks.
Okay, I would like to really thank you, Mr. Kaziva, and the whole help team for organizing these discussions. I guess somewhere they will be helping someone. Someone might pick a thing or two. And I want to thank all the participants that came in today. I thank all those who attended, all those who paid their, brought in their contribution and their participation. Thank you so much. I would like to end here and wish you a good evening. We can continue sharing on other media platforms, and if maybe time allows, we shall continue sharing here. Thank you so much.
Okay, Teacher William, I'm going to kindly request you to drop your number in the chat such that people can reach on to you for further consultations, if you do not mind, because I know some students may need to reach you, some schools may need to reach on to you for more clarification. I want to thank all the teachers. I want to start with Teacher William. We are really very grateful for your sacrifice and for putting in your time. We can't not thank you enough, but we are really very grateful. Thank you so much for the wonderful presentation. And at least I know one time we shall be able to reach to Mitoma to meet physically. But we are really very grateful. Thank you so much. We want also to thank all the schools that have really joined this call. Thank you so much for your time. We want to thank all the students that have been on from the time we started at 4:30 up to this time. Thank you so much for sacrificing your time to go for other activities, but to dedicate this time for academic work. May the good Lord bless you, and may he give you all what you desire to have at the end of your journey as you sit for your final exams. We want to appeal to you that always have all those questions that we have shared with you. Do all the table work. Let us do all the table work, and then let's give our teachers to mark. I know Teacher William will share with us his final tables, and then we shall be able to share with you such that you look out and mark yourself. After that, we want you to try out the graphical work. Let us try out the graphical work, because that's where we are going to earn the marks. Later, the table earns marks, the graphical work earns marks. So we must collect all the graphs. And remember, we told you that once you pass the practical, higher chances are that you are going to have good marks. You are going to have your distinction already sealed. So let us practice the graphical work and the table work such that at least at the end of the day, we are perfect at those two things. We want to thank you so much, and we want to say, let's meet tomorrow. Tomorrow we are having history, and we shall mainly handle history East Africa, and also we shall handle history of South Africa. Let's meet tomorrow. In case you have any questions about those two papers, kindly let's meet tomorrow. Maria Sumpta, we love you so much, and all the schools, Kakira, and let's meet tomorrow. Teacher, take for us some photos and you can share with us such that the minister can as well be able to see you. Thank you so much, and bye-bye, everyone. Bye. Bye-bye.